Hello friends, now we have to solve the given second order linear differential equation with constant coefficient. You can see here this y double dash plus y dash minus 2y is equal to x plus sin x. This is the given differential equation. Y double dash can be written as d2y by dx2 and y dash this can be written as dy by dx minus 2y is equal to x plus sin. You know that there is second order differential coefficient present here. So this is the second order linear differential equation and the coefficient of dy by dx is 1 and the coefficient of y is minus 2 which are constant. So this is called linear differential equation with constant coefficient and this is the second order linear differential equation. Differential equation with constant coefficient. You know that this is the second order linear differential coefficients, second order linear differential equation with constant coefficient. Because there is only a second order differential coefficient of dependent variable y with respect to independent variable x is present. Now this can be also written as d2y plus dy minus 2y is equal to x plus sin. Now we taking common y, so we get d square plus d minus 2 times y is equal to x plus sin. Here d by dx can be written as capital D and d2 by dx2 can be written as capital D2. So the given differential equation can be also written as. Now we find the auxiliary equation. So for forming auxiliary equation we replace this capital D by small m. So m square plus m minus 2 is equal to 0. Now we can see here this is the quadratic equation. So solve this and get the roots of this equation. So this m square plus 2m minus 2 equal to 0. Taking common m here we get m plus 2. Taking common 1 here we get m plus 2. So m plus 2 taking common we get m minus 1. So m is equal to 1 and minus 2. These are the roots of this auxiliary equation. Now we write here complementary function. So the complementary function can be written as c1 e to the power m1x plus c2 times e to the power m2x. You can see here m1 is 1, so this is x, and c2 is power m2 is minus 2, so this is minus 2x. So the complementary function is c1 e to the power x plus c2 e to the power minus 2x. Now we find the particular integral of the right hand side. So particular integral, first we find the particular integral of x. So this is 1 upon fd is d square plus d minus 2 of x. Now for particular integral we take common this minus 2 and this can be written as 1 minus d square plus d divided by 2 whole power minus 1. Now we expand this and you know that the expansion of 1 plus x to the power n is 1 plus nx plus n minus 1 by factorial 2 x square. Using this expansion and get the expansion of this, and we take those terms in the expansion in which the power of d and x both are equal. When we expand this, we take only those terms in which the power of d and power of x both are equal. So we write here only 1 plus nx. N is minus 1 and x is this 1. So minus 1 and minus times we write here 1 plus minus 1 and minus times d square plus d divided by 2. We take only those terms in which the power of d and x are equal. Here the power of x is 1, so we take only those terms in which power of d is 1. Now we solve this. Here when we expand this, we take only two terms, because in the third term the power of d is square and higher power. So we take only two terms in the expansion of this. Now this can be written as 1, this minus minus plus, and we take only d by 2, because in power of d is 1, but in this d square power of d is 2 and the power of x is 1, so we not take this d square term, we take only d by 2. Now we multiply this x inside the bracket and get pi1 is equal to minus 1 by 2 x plus d by 2 of x. Now minus 1 by 2 x plus 1 by 2 and d of x, that means we differentiate this x with respect to x, we get 1 only. So this is minus 1 by 2 x plus 1 by 2. So this is minus x by 2 plus 1 minus 1 by 4. Now this can be also written as 4 minus 2x minus 1. So this is minus 2x plus 1 divided by 4. So we get the particular integral of x. Now we find the particular integral of sin x. Now we find the particular integral of sin x. So pi2 is 1 upon fd, that is d square plus d minus 2, and here is sin x. Now you know that when we find the particular integral of sin ax, we replace d square by minus a square, and minus a square, f minus a square not equal to 0. You know that when we find the particular integral of sin ax, we replace d square by minus a square. So here we replace d square equal to minus a square, and a is the coefficient of x. Here the coefficient of x is 1. So this is minus 1 square. So this is minus 1. So we replace d square by minus 1. So minus 1 plus d minus 2 of sin x. So this is d minus 3. Here 1 sin x. Now we multiply by d plus 3 in the numerator and denominator. We get d plus 3 divided by d square minus 9. Now we replace this d square by minus 1. So we get here minus 1 minus 9 of sin x. So this minus 9 and minus 1, this is minus 10 and d plus 3 of sin x. Now we multiply this sin x inside the bracket, so we get d of sin x plus 3 of sin x. D of sin x, that means differentiation of sin x with respect to x. So differentiation of sin x is cos x. So this is minus 1 by 10 cos x plus 3 sin x. Now we find the general solution of given differential equation is y is equal to complementary function plus particular integral. So complementary function is c1 times e to the power x plus c2 times e to the power minus 2x plus particular integral is minus 2x plus 1 divided by 4 minus 1 by 10 times cos x plus 3 sin. So this is the general solution of the given second order linear differential equation with constant coefficient. Thank you.